Hi, I'm Pete.
I'm Jacob.
I'm Charles.
And today we're going to show you a little bit about sound transmission loss testing with an impedance tube. I'm going to start the software here. And you can see that this has come up with a channel setup that has 4 microphones. And we're going to surround this test sample, that's this little white piece of foam here, or the gray piece of foam that we're going to test, with these 4 microphones. We got microphone A here, which has got a little blue tag, microphone B with an orange tag, and then on the other side, microphone C and D with green and white tags respectively. Before we get started, we have to do something called a phase calibration. Maybe even before you do the phase calibration, you want to make sure that you have the right sensitivity values for the microphones and do a microphone cal if necessary. In phase calibration, we're going to start by measuring all the microphones in their standard position. Before I do that, I need to make sure my amplifier is on here and turned up, which it is. And then I'll hit measure standard positions. Goes out and measures an FRF between all the microphones that it's going to use as part of the phase calibration. It's a multi-part thing, so the next step, we need to swap some of the microphones. We need to swap microphone A with microphone C. So Jacob, what does that look like in there? The microphone is all the way through that black collet.
Also, make sure that the top is tight at all times.
All right. You're swapping it. You put the microphone all the way down so it can't go any further, and then you're tightening it with the black collet. Is that correct?
Correct.
Is it called a collet or a whatchamahoozy, Jacob?
I'm not sure.
Oh. All right. So we've done our swap here, and we're ready to measure our next transfer function. And after we've done this measurement, we want to swap the microphones back, and then we're going to do another swap. Is that right?
Yes.
So we're putting A and C back in their original positions. And then we're going to put B and C, swap those. So C, we don't even have to put back in again. We're taking out B. And now orange and green are being swapped here. All right. Now they're tightly in place and I can measure the transfer function. Notice how quickly I hit that, guys. We're just like a NASCAR pit crew here, aren't we? Okay, and now we have one more swap. We have to put B and C back in their original positions, although C we could probably keep out. And then we're going to swap C and D. We're doing all of this with a anechoic termination. And with the tube perfectly empty. All right, now we're ready to measure our next transfer function and last transfer function. And we wanted to return the microphones back to their original positions. In the STL tube, I'm going to use the phase correction from the active section. The green here indicates the phase calibration measurement has been done. I'm ready to test our first sample too once the microphones are back in place. Which one are we going to measure, the white or the gray, Charles?
The white.
We're going to go for the white sample. You're picking that because you figure it's got pretty good transmission loss?
No.
Okay. Well, let's try it. So we got the white sample here. It's going to go in. It's going in this little section in between the 2 microphones. It's been cut perfectly to match the outer dimensions of the tube diameter. And we're going to measure the anechoic termination. Notice I could go in any order, but we want to measure two conditions, anechoic and rigid. And now the next and final step will be to measure the rigid termination. Let's take a look at that anechoic termination there, Charles. What can you tell me about that?
The anechoic has material inside of it.
It absorbs all the sound, huh?
Correct.
Okay. And this rigid, no material. It's just a rigid connection. All right. What do you think this transmission loss will be like, Jacob?
Most likely minimal, around 5 decibels.
Minimal, around 5 decibels. Well, let's take a look here. I'll set my scale 0 to 30 here. I'll stick on a cursor. It's in the range of 5 decibels. I don't know. Is that a lot of transmission loss, Charles?
No, it's minimal.
Yeah, something like if we had a barrier there, it could be like 90 dB of transmission loss if it was good.
Yeah,
Yes.
maybe we can try also putting in the second sample along with the white one.
Oh, you mean like if we double up on samples and
Yeah.
might? Yeah, let's try that.
All right.
Oh, I'm going to write that we're doing a double sample here. Hit return. Now I have to measure rigid and anechoic again. We have the rigid connection in right now, so I'll pick rigid after Charles does this. And now we're going to swap in the anechoic termination. That's pretty fast. So 5 dB from the white sample, the gray sample, another 5 dB. You're thinking 10 dB, Charles?
Yeah, probably around there.
Probably around there. All right, let's see. Ooh, hey, it almost doubled. That's cool. And that is how you measure the transmission loss of a material. Thank you very much for listening.